Hello everybody, in this video we're going to be talking about trend lines and fitting them to data in Scatterplots. As you can see in this scatter plot, the trend line is right here. Notice how it is going through the middle of the data, and it's also angled and pointed in the same way. That is the best fit line. The name of the trend line is sometimes called the best fit line for that reason. Now to make an equation of a line, we need to reference y equals mx plus b, the slope-intercept form of any line, any linear equation. The b is the y-intercept, and as we can see right here, it's crossing at 110. That's going to be our y-intercept. That number goes in for the b variable. We're going to leave x alone. We're going to leave y alone. We'll also leave the equal sign alone. Now the next thing we're going to do is find the slope. We can find the slope between pulling out just two dots here, and notice we go down 2 and to the right 1. Down 2, right 1 gives us a slope of -2/1 for going down and to the right. We can write -2/1 as just plain old -2. So our equation is going to be y equals -2x plus 110. Now, something else to note, this equation can actually be written in terms of n and m variables. So we could say n equals -2m plus 110. And that's the equation of the trend line through this data. Alright, let's look at this one here. It says the scatter plot shows the relationship between the number of car accidents in a month and the number of drivers attending a program on distracted driving. The equation represents the linear model for this data. Y equals -0.0067x plus 17. What does the number 17 mean in this context? Okay, so let's get our y equals mx plus b so we can kind of compare those two. Y equals -0.0067x plus the 17. From a pure mathematical point of view, the 17 is the b, it's the y-intercept. We see that right here, don't we? But in terms of the context of the problem, the 17 says when 0 students are in the program, the accidents per month were at 17. But as you can see, over time, as more and more drivers got enrolled in the program, the number went down. But starting out, the starting amount, there were 17 accidents per month when 0 drivers were in the program. That is what the number 17 means in this context. Let's look at another one here. Scatter plot below shows the number of pizzas sold during weeks with different numbers of coupons were issued. The equation represents a linear model, y equals 3.4x plus 43. According to the model, how many more pizzas are sold for each additional coupon issued? Now, it's not very obvious, the wording of the question, but what the question is asking for each additional coupon, it's asking for the rate. Okay, and in y equals mx plus b, the m is, yes, mathematically the slope, but it is also the rate in the problem, the given rate. So let's match up this equation here. Y equals 3.4x plus b, or plus 43, I should say, if we plug in the numbers. As you can see, the m number is the slope right here. 3.4 more pizzas are sold per month, or 4 pieces are sold nightly for every 1 additional coupon. Alright, so for instance, let's say 5 coupons are issued. Then they're going to sell about 3.4, about 3 more, as you can see from the previous dot. Okay, so they were at 4 here, so it goes up about 3.4 pizzas, about 3 pizzas, about 3.5 pizzas. But yeah, the point is this number here, this is the rate. This is how many more pizzas are sold whenever an additional coupon is issued. Alright, that's it for this video. Thank you for watching.